Hi everyone. In this video, we want to talk about how to calculate percentiles of a continuous random variable. So let's start off at looking at what is a percentile to begin with. The kth percentile is defined as a score that holds k% of the scores below it. So if you have some distribution and you find the kth percentile, then the kth percentile is simply that value that divides your distribution so that k% is to the left of that value. So let's recap a little bit to something which you may be familiar with. Suppose you have your data represented by this line. So in other words, 100% of your data is represented. So this is from the lowest value to the highest value. I could divide this distribution into 4 equal parts. So you end up with 25% here, 25% here, and so on. So typically, for some of you, you might be familiar with the term quartile. So your first quartile lies over here, your median lies over there, and your third quartile lies there. So simply put, what a quartile is, it's pretty much just that value that splits up all your data so that 25% is to the left and the rest is on the right. The median splits up your data so that 50% is on the left and 50% is on the right. And then the third quartile splits up your data so that you have 75% on the left and then the remaining on the right, naturally. So now to bring it down to percentiles. Q1 can also be is equivalent rather to your 25th percentile, which makes sense. So remember your kth percentile splits up your distribution so like k% is to the left. So at this point at Q1, 25% is to the left. So we call it the 25th percentile. Similarly, with the median, I hope you see where we're going. 50% lies to the left, so we call it our 50th percentile. And lastly, our 75th percentile, because 75% of your data lies to the left of that particular percentile. So we want to figure out, how do we calculate these percentiles? We can ask for any percentile. It could be the 10th, it could be the 5th, the 95th percentile. It doesn't matter. The calculation is still the same, and that's what we want to focus on in this video. Before we go any further, let's have a look at two examples where you'd have percentiles come up in different scenarios. So the first one is just a different interpretation. So consider this statement. The 40th percentile can also be interpreted as the score that exceeds 40% of all scores and is exceeded itself by 60% of all scores, which makes sense if you just take a moment to think about it. Let's look at this second statement, also quite interesting. So if, let's say, your lecturer comes to you after handing out a class test and says that, dear students, the 75th percentile of class test 1 is 50%. And hopefully you interpret this as a horror, because what this means is that 75% of all the test marks are below 50%. So, in other words, let's say 50% obviously is your pass mark. Since it is the 75th percentile, that means that 75% of your population, or that means your test scores, that's your population, 75% are below 50, and that means 25% are above 50. So, in other words, 75% of the class failed and only 25% of the class passed. So that's just a nice example for you to just understand what kind of information you get when you're told about a percentile or if you report on one. So let's get into the nitty-gritties. Here is a more formal definition of a percentile. Suppose you have some value p that is between 0 and 1. Then the 100th percentile of the distribution y is that number c such that the probability of y being less than or equal to c is equal to p. So let's just unpack this for a moment before we go any further. So consider this example here. If I said I have the 10th percentile, then if I want to use this notation, then obviously the 100 is fixed. And then in this case, P is obviously going to be 0, comma 1. In this second case, we have the 50th percentile or the median, and obviously P is going to be 0.5. So hopefully you're starting to see the pattern in all of these different cases. And one way of looking at it that is really helpful is this percentile gives you the percentage that is to the left of a value, whereas P is the proportion that is to the left of a value. So you never need to go and actively do this calculation. Just convert the percentage into a proportion and you'll have your P. So now if we come back to our example, that means the probability of Y being less than whatever value C is equal to P. In other words, the proportion of your distribution is P. That is to the left of your C. So I'll show you graphically so it'll be easier to see. So you'll notice that in your textbook, when they talk about this, they actually don't use the letter C. They use this symbol here. This curly looking N is actually called eta or eta. I'm not really sure how I pronounce it, but I call it eta, and they then put the subscript P. So it's quite a nice notation because immediately you know which percentile you're talking about, because you know if they say eta 0.1, then you know that it's a 10th percentile. But I chose to use the letter C just for simplicity. In a test or exam, if you use C or eta P, depending on the question P, you'll define that. I will mark both examples, don't worry. Everything is fine if you use eta or C. So there are two ways of calculating your percentiles. Just like there are two ways of finding this probability, you can use your CDF or your PDF. So I'm going to show you how to do it in both cases, and you need to be able to do this. So let's start off, let's say I give you a PDF. Okay, so let's take an example. Suppose we have this distribution, so it's a nice curve like this, and I've drawn your PDF. Okay, so if I ask you to find C, all right, such that the area to the left is P, then you can actually just arbitrarily just draw a C on your graph like this one. And what the 100th percentile tells you is that P is to the left of this. So in other words, the area, because remember when we talk about a PDF, we always refer to the area under the PDF being that proportion or probability. So this whole area here is equal to P. In this example, let's say the 85th percentile is required. Then quick, 85% expressed as a proportion is 0.85. So in other words, 0.85 is to the left of C. So if I ask you to calculate this, so I want you to think of it this way. Every time you ask to find a percentile, think of it as doing everything that we've been doing up until this point backwards. So in all the previous lectures, I told you what C was, and then I asked you to find a probability. Now it's backwards. I'm giving you P, and I want you to find C. So it's like finding a probability backwards. So I've already given you P. You know that it's 0.85. So all you need to do is form an equation in C and equate it to P. Okay. So this is what your equation would look like. So we know that the area under the graph from minus infinity up to C should be equal to 0.85. So this is the integral. So from minus infinity to C, you integrate over your function, and that's going to be equal to 0.85, the area to the left. So in general, you'll always form this kind of an equation when you have a PDF. There'll be some integral, and then C is going to be in the bounds. Now, alternatively, you could have looked at this question a slightly different way and still gotten the right answer. Sometimes it's easier to look at it the other way around and use the complement rule. So naturally, if 0.85 is to the left of C, then 0.15 is to the right of C. So you can actually write an equation to solve for C, but using the area on the right. So this is what your equation will look like. If you integrate from c all the way to infinity over fy, you should get 1 minus p. So this is just an alternative that you can consider. So just do whatever makes sense and whatever is easiest in a test. Both of the ways of doing this will be marked and will be considered. You will come to the same answer provided you do it correctly. So let's have a look at this exercise. I have x, which is a continuous function with this PDF, and we want to look at the 60th percentile. I suggest you perhaps try it on your own and just see if you're able to do it, but I'm still going to explain it to you and show you how to work it out.
So in this question, we have been asked to find the 60th percentile. So remember, the 60th percentile is simply that value. So I'm going to call it C, such that the probability to the left is 0,6. So remember, when you have a PDF, you are going to integrate. So we want to integrate something up until x should give you 0.6. So we have a little bit of a dilemma here. Remember, if c supposedly is in this region, right, then we're just going to integrate over the one function. That's this first one here. But if c is in here, then we need to integrate over this region and that region as well. So we first need to determine which region C is in, and then we will formulate an equation based on that. So what you can do first is now try to determine, okay, is it in the first interval or the second interval? So what I'm going to do is I'm going to integrate over this first region here. I'm going to find out how much probability is in that part of the graph. So in order to do that, I'm going to integrate from 0 to 1, and this function is x squared. So here's my integral. I've already done it for you. And if you integrate from 0 to 1, you get the answer 1 over 3. So immediately you can see that 1 over 3, which is in essence 0,333 and so on, is actually less than 0,6. So there is no way that c can be between 0 and 1. Because if c is between 0 and 1, then the probability to the left of c is always going to be 0.3 or lower. Okay, so we know that it's definitely in the second region. So I'm going to indicate that. So let's say c is over here. Okay, so now the question is, what is c? I know that the area to the left of c is going to be 0,6. So I need to formulate an equation in order to calculate that. So what I'm going to do is I'm going to integrate over this entire region here, all of that. If I can integrate all of that up until c, this must be equal to 0,6. So there are two ways of doing it. I'm going to show you the first way. So the first way is given here in this equation. Okay, so we want to integrate from 0 to c over our function. But remember, c is sitting in the second region, so I'm going to have two things to integrate over. I need to integrate over 0, 1 in the first region, x squared, and then from 1 to c on the second part of fx. So if you substitute the relevant functions, here it's now x squared, which I already calculated previously. So we did it already in here. So I'm just going to go straight and write the answer to be a third. And then here the function is going to be 2 over 9 from 1 to c. So if you do the integration, you get 2x over 9, and then you continue here. Remember, it's upper limit minus lower limit. So you have the c and the 1 substituted, and then you find the difference. And ultimately, you can do this for yourself and verify. The answer is going to be 2.2. And you can actually verify this if you just take your answer and put it in there, whatever you get, and then check if you get the correct percentile. Do you get 0.6? So that's something you can do in your own time or in a test if you have time to go back and check. That's how you're going to know if you did the correct thing. Now for the second method. Okay, so I know that the area in this region here is 1 over 3, right? But I know that the entire area from 0 to C is going to be 0, 6. So how about I just focus on this region, right? So I can actually formulate a somewhat similar equation. So I know that the area in this region is going to be 0, 6 minus 1 over 3. Okay? And then I already did that calculation. It's actually going to be 4 over 15. So now I can do an equation from 1 to C and say that it's equal to 4 over 15. So that's what I've done lower down here. Because I know that from 1 up to C, I'm only left with 4 over 15. Remember, the third is already gone. So it saves me having to do that all over again. And here you have a somewhat simpler equation. So I know that the area should be 4 over 15 in the region where the graph is 2 over 9. So if I do the integration, you get pretty much the same as in the last one, exactly what we got here. So you simply need to solve for C and you come to the same answer. And you can do the exact same check once again to see that you got the correct answer. So that's how you're going to calculate a percentile. So rather than memorizing a formula, understand what a percentile is and then create an equation. That's simply all you have to do. And as I said, finding a percentile is like going backwards. Instead of finding a probability, I give you the probability and then you need to find the value that is on the number line. So in this case, it's X. It could be Y or Z. So just think of it that way and it might help you start.
Great. So that is how you'd work out that example. So now let's consider the second scenario. What if I give you a CDF? So remember, if we graph a CDF, you'll typically have something like this, but not necessarily. The key is that it's always going to be a continuous function. Remember, if it was discrete, then you'd have steps. So here it's nice and continuous. And just a quick recap, if I'd asked you to find the probability that x is less than or equal to some value of x, for example, x equal to 4, then this is already, remember when you get the function of fx, the integration is already done. So you just need to plug in f4 because this thing is equal to f probability of x less than or equal to 4. So this you should know by now. And if I'd asked you to do it using a graph, suppose I hadn't actually given you the functional form, but the graph, then you'd go to the value of 4, you'd go up and then across, and then that would give you f4. So now coming back to our percentiles. This is the equation we're focusing on, but we already know that there's actually a function for this, and we call it the CDF. So in other words, we actually want to form an equation where we have f of c and make it equal to p in order to find the relevant percentile. So let's take the 85th percentile like we did previously. And so remember I told you it's like going backwards when you try to find a percentile. So instead of being given 4 and then going up to the line and then on the vertical axis, you're going to go to FC equal to 0.85. You'll go across and then you'll go down. So it's literally going backwards. And then you want to solve this equation. So remember you have your functional form of F, your CDF. You'll just substitute C in the relevant equation and equate it to 0.85. So just a quick recap, from calculus. So you just see that this is nothing new and you're familiar with it. Suppose I'd given you an equation like y is equal to x plus 1, and I told you that y is equal to 4. you would have just substituted 4 in this equation, and then you would have gotten x is equal to 3. So similarly, suppose I give you a function hx, because we're typically dealing not with y, but more with a function like this. So let's say I said hx is equal to 4 for some value of x. You would have just taken this hx equal to 4 and substituted in this side of the equation. And then on the right-hand side, you leave it the same. And then you'd solve 4 equal to x plus 1, and you'd come to the same answer, x is equal to 3. So you're going to do the exact same thing. We have fc is equal to 0.85, and then you'll have f of c somehow. So when I do an example with you, you'll see. So in a nutshell, this is how you're going to solve it. Let's do a quick example. So here we are given the CDF of x. We've been asked to find the 10th percentile. Let's have a look at how we do this.
In this example, we've been asked to find the 10th percentile. So in other words, we want to find the value of C such that the area or the probability to the left of it is 0, 1. So in this example, we've been given a CDF instead of a PDF. So remember, I told you that when you get a CDF, you must never integrate because the integration's already been done. But we know how to calculate this thing in two ways. With a PDF, and then when we have a CDF, it actually is already equal to that. So in other words, we've actually been asked to find f of c at 0, 1. Okay, so now we look at the function and we need to solve for c. But we have a little dilemma. We have different equations. We have this one and this one. So the question in this example is, in which region is it? So we need to test it out. So this is what I recommend. Okay, so let's start off with the first region. Is the value we're looking for in the first region? So the first region runs from 0 to 1. So let's take the upper bound and see what's the maximum probability that we can get for this equation, x cubed over 3. So I just take that upper bound, and then in this step, I just calculated what's f of 1. In other words, what is the area to the left of the value of 1? And you actually get 1 over 3. And immediately you can see that 1 over 3 is less than 0, 1. So this tells us that the probability that we're looking for is actually going to be in the first region. So you always need to check this. Just for completeness sake, suppose I'd actually asked you to find the 75th percentile. So you'd find that, okay, obviously 1 over 3 is much smaller than 0.75, so it's got to be in the other region. So just to see what happens if I put F4, then I took the upper bound as well. And this is equal to 1, okay? Understandably, because the CDF is always going to be continuous if the random variable is continuous. So if I'd asked you for the 75th percentile, let me write it down for you. If I'd asked for the 70th one, then you would have known that C is in between 1 and 4. Okay, because you know that 0.75 is going to be bigger than 1 over 3. So it's going to be in the next region. So this is a nice simple one. So this, you don't usually have to do this. Once you found the region, don't worry about it. This isn't necessary. This is just for completeness sake. So you can just see how this works. So now we know that C is between 0 and 1. So all we need to do is now just solve for the equation between 0 and 1. So between 0 and 1, the equation for fx is x cubed over 3. So I just take f of c. So now I'm focusing on this now. So I already have the right-hand side of the equation, which is here. And then the left-hand side, I want my f of c. So now we have c cubed over 3. So that's the left-hand side of that equation. And now if you solve for 3, you get 0, 669. So you'll usually find that in a test, if you have an option of using the CDF or the PDF, the CDF is going to be a lot less work and usually a lot easier. But if you're not told which way to do it, yeah, go ahead, do it whichever way you like. And if you're told, you need to do the way you're told. So make sure you know how to do it both ways. And then just like in the PDF case, you can verify that you got the correct answer. So now just calculate x less than or equal to your answer, or in other words, f of your answer, and then you just check. This example ends up being approximately 0.1 because of the rounding here, because we had to find the cubed root. So that's why I have the approximate symbol in this case, but it should be very close to the answer if you did round off. So this is how you'll do it if you have multiple different bits. If I had given you an equation that only had one function, so in other words, if you had some fx where you just had 0, 1, and then some function in there, then you don't have to do this check that we did in this step, because obviously it's going to be in this region. And similarly, I didn't get to mention it earlier, if you have a PDF, if you only have one equation and let's say it's 0 elsewhere, then obviously your percentiles are in this region. So I decided to do the more complicated case for you so that you're equipped to do the simple ones. The procedure is the same. So like I said before, try not to memorize formulas. Understand what you're doing and what you are looking for. And then you'll be fine no matter what equation you get.
This equation happens to be the exact CDF that corresponds to the PDF in the previous example. So I would like you, on your own, try calculate the 60th percentile as well, and then just see what answer you get. You should get 2.2, and just try use the CDF and make sure that you're able to get the correct answer. And then you can also try B as a second example. So sometimes you'll see that we ask for the median. So you just need to remember that the median is the 50th percentile. So that means the probability to the left is 0.5. And the answer that you should get is 7 over 4 or 1.75. So just see if you can do that for yourself. So, in conclusion, just as an overview, as I told you, you preferably don't want to memorize a formula, but try to understand what you're doing, and it'll be way better. So, in a nutshell, remember it's always the area to the left of some value C. I'm looking for C, I've been given P. So if I'm given a PDF, then I'm going to integrate from minus of to C, and that must be equal to P. And if I'm given a CDF, then F of C should be equal to P. So I simply need to solve the relevant equation depending on the question that I was given. So just watch out for whatever you're given in a question, because things will definitely be mixed up. That brings us to the end. I hope you were able to follow. Have a good day.